Hello friends, welcome to today's lecture Introduction to Applied Mechanics. Myself Mr. Yogesh Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Jagrao. In this lecture, we studied fundamental of statics, force, system of forces, composition of forces, resolution of forces, equilibrium, centroid and center of gravity, and stresses. Let us see one by one. First, fundamental of statics. Mechanics, it is a branch of engineering which deals with the action of forces acting on the body either in rest or in motion. Engineering mechanics divided into two parts. First one is static, means body at rest condition. It is a branch of mechanics which deals with the action of forces acting on the rest body, means it is a statics. Next one is dynamics. Dynamics means body in motion. It is a branch of mechanics which deals with the action of force acting on moving body. Dynamics once again divided into two parts. That is, first one is a kinetics, body in motion due to external force. It deals with the study of forces which produce the motion in the body, and in kinetics mass of the body is to be considered. Next one is a kinematics. Kinematics means body in pure motion. It deals with body in pure motion without considering force which are responsible for the motion, and in this condition mass of the body is neglected. Then next, force. Force is an external agent which produces the motion in the body or change in the motion of the body or check the motion of the body. Means due to that external force, the body start from static position to the dynamic position, or in dynamic to the static position due to that external applied load. Then next we see characteristics of a forces. Suppose this is a force F is equal to 10 Newton at an angle of the 50 degree in first quadrant. I want to identify characteristics of a particular force. So first is the magnitude of force. For this force, magnitude is 10 Newton. The magnitude of force is equal to 10 Newton. Then next, direction of force. Direction of the force means the force lies in which quadrant? First, second, third or fourth. Basically this force lies in a first quadrant. And inclination with respect to x or y. This is a 50 degree with respect to x. So direction is northeast first quadrant, 50 degree with respect to x. Then nature or sense of the force. Basically nature of the force means compression nature or tensile nature, or sense of force means pull nature, pull sense or push sense. Pull means what? The force go away from the origin, that is called as pull nature force, and if the arrowhead or direction of the force towards the origin, it is a push nature force. This is a pull nature force. Then point of application of force. Where it is the point of application of that particular force? This is origin O. This is the point of application. Then system of forces. Basically 8 system of forces. First, coplanar force system. Second, collinear force system. Third, concurrent force system. Fourth, parallel force system. In parallel force system, subdivided into two parts, that is like parallel forces, B unlike parallel forces. Fifth one, coplanar concurrent force system. Sixth, coplanar non-concurrent force system. Seventh, non-coplanar concurrent force system. Eighth, non-coplanar non-concurrent force system. Let us see one by one. First is a coplanar force system. Coplanar force system means the all forces lies on a single plane. That system called as coplanar force system. Second one is collinear force system. In collinear force system, number of forces acting on a single line of action means, see this figure, the P1, P2, P3, P4, 4 number of forces acting on a single line of action. That force system called as collinear force system. Next, concurrent force system. In concurrent force system, all forces meets on a single point. That particular system called as concurrent force system. Then parallel force system. In parallel force system, in subdivided into two categories. First one is like parallel forces. Like parallel forces means the all forces are parallel to each other but going in a same direction. That system called as like parallel forces. And unlike parallel forces means the all forces are parallel to each other but opposite in direction. Means this out of these five forces, four forces going in upward direction and one force going in a downward direction. This system called as unlike parallel forces. Then coplanar concurrent force system. In coplanar concurrent force system, the all forces lies on a single plane and passes through a single point. That system called as coplanar concurrent force system. The next, coplanar non-concurrent force system means all forces lies on a single plane and forces passes through a different points. That system called as coplanar non-concurrent force system. Then non-coplanar concurrent force system. In this system, the forces lies on a different planes but passes through a single point. See this P1, P2, P3, P4. Four number of forces acting or passes through that origin O. So this is the concurrent force system, and P1 force lies back side of the body, P2 bottom side of the body, and P3 and P4 left face of the body. So four forces acting on a different planes but passing through a single point. That's why this system called as non-coplanar concurrent force system. Then last system is non-coplanar non-concurrent force system. In this system, the number of forces acting on a different planes and different points. So that's why it's called as non-coplanar non-concurrent force system. P1, see here, P1 force acting upper face of the body, P2 back side of the body, P3 front side, P4 right side of the face of the body. So all forces acting on a different plane and different points. That's why it's called as non-coplanar non-concurrent force system. Then next, composition of forces. Basically, composition of forces means what? The process of determine of resultant of force in a force system is called a composition of forces. In other words, suppose see as figure, this is the x component, this is the y component. That x component force is summation fx, y component force is summation fy. I want to replace these two perpendicular components into a single force, that is resultant force r at an angle of theta. So this system called as composition of forces. Means two perpendicular components convert into single force, that is called as composition of forces. Next, resolution of forces. The method of splitting a force into its component, that is two perpendicular components, without changing the effect on the body is called as resolution of force. Means resolution of force, it is exactly opposite of composition of forces. In composition of forces, we convert two perpendicular components in a single force, and in resolution, we split a single force into two perpendicular components. Now, this is a F force at an angle of theta. I want to convert or I want to resolve this force into two perpendicular components, that is Fx and Fy. This theta with respect to x. So Fx component will be F cos theta and Fy component will be F sin theta. This is by using simple trigonometry. Let us see one example. I want to calculate two perpendicular components for this force F is equal to 20 Newton at an angle of 50 degree with respect to x. So I want to resolve this force Fx and Fy. For Fx is equal to F cos theta and for Fy is equal to F sin theta. So Fx, first we calculate Fx is equal to F cos theta. F will be 20 and cos will be 50. So 20 cos 50 is equal to Fx is equal to 12.85 Newton towards east direction. When you have this force, x component going towards the right side. Next, Fy will be F sin theta. So F will be 20, sin theta will be sin 50, and the direction of the force going in a upward direction. So Fy will be 15.32 Newton and the direction is towards north. Next, equilibrium. The analytical conditions of equilibrium is three conditions. First, summation fx is equal to 0. Summation fx is equal to 0 means the algebraic sum of all horizontal forces should be equal to 0. Then summation fy is equal to 0. The summation fy is equal to 0 means the algebraic sum of all vertical forces should be equal to 0. And summation m is equal to 0 means the moment about any point is equal to 0, means clockwise moment is equal to anti-clockwise moment. Then types of supports and reactions. Basically, four types of supports we considered for analysis of beam. First one is a simple support. For simple support, number of reaction is 1. Then second one, hinge support. The number of reactions for hinge support is 2, that is vertical and horizontal. Third one, roller support. For roller support, number of reaction is 1. And last one is fixed support. For fixed support, number of reaction is 3, vertical, horizontal and 1 moment. Then next, center of gravity. The center of gravity means the whole mass concentrated on a single point, that point called as center of gravity. Center of gravity deals with the mass. And how to calculate that CG for any section is x bar is equal to summation of Vx upon summation of V, and y bar is equal to summation of Vy upon summation of V. Then centroid, the whole area concentrated on a single point, that point called as centroid. And the how to calculate the centroid for any figure is x bar is equal to summation ax upon summation a, and y bar is equal to summation ay upon summation a. The basic difference between center of gravity and centroid is CG deals with masses and centroid deals with area. This is some basic geometrical figure. Centroids. For first is a square. For square, x bar and y bar are both are same, that is a by 2, and this is measures from left side and bottom of the side, that x axis and y axis. Then rectangle, this rectangle having width b and depth h, so x bar is equal to b by 2 and y bar is equal to h by 2. Then right angle, from right angle x bar from this origin is b by 3 and y bar from this origin is h by 3. Then equilateral triangle, the x bar will be b by 2 and y bar is h by 3. For circle, the x bar and y bar is same, that is d by 2 or radius. For semicircle, the x bar is d by 2 or radius and y bar from bottom of this or that from x axis is 4r upon 3 pi. For quarter circle, from this face, the x bar will be r minus 4r upon 3 pi and y bar will be 4r upon 3 pi. Quarter circle for this position is x bar and y bar are same, that is 4r upon 3 pi and y bar also 4r upon 3 pi. Trusses. Truss. First of all, we discuss statically determinant truss. What is meant by statically determinant truss? The truss which analyzed by using these three equations, that is summation fx is equal to 0, summation fy is equal to 0 and summation m is equal to 0. By using these three equations, if truss is analyzed, then this truss called as statically determinant truss. Then next, perfect truss or stable truss. Perfect truss or stable truss is that which composed of members just sufficient to keep it in equilibrium when loaded. Means this equation is satisfied, that is m is equal to 2j minus 3, where m is equal to number of members, j is equal to number of joints. So let us see one example. A ABC truss. The number of members in this truss is 3, AB, BC and AC. M is equal to 3 and J is equal to 3, that is A joint, B joint and C joint. So M is equal to 3, J is equal to 3. Put up this all equation in this equation, all values in equation. M is equal to 2J minus 3, that is 3 is equal to 2 into 3 minus 3. So 3 is equal to 3, that is RHS is equal to LHS. This is a perfect truss or stable truss. Then next, imperfect truss or unstable truss. A imperfect truss is that which is composed of member not sufficient to keep equilibrium when loaded. Means is simply the equation is m is equal to 2j minus 3 is not satisfied. Imperfect truss divided into two types. First one is a deficient truss. A imperfect truss in which the number of member less than 2j minus 3. Let us see one example. A rectangle truss, the member of this truss is 4, 1, 2, 3 and 4, and joint also 4, 1, 2, 3 and 4. So m is less than 2j minus 3. So m is equal to 4, j is equal to 4 into 2, 8, 8 minus 3 is 5. So this equation becomes 4 is less than 5. So this truss called as imperfect truss or deficient truss. The next one is redundant truss. A perfect truss, imperfect truss in which the number of member is greater than 2j minus 3. So see one example, a rectangle truss having two inclined members. So number of members is 1, 2, 3, 4, 5 and 6, and number of joints remain 4, 1, 2, 3 and 4. So in redundant truss m is greater than 2j minus 3. So m will be now 6, j is equal to 4. So 4 into 2, 8 minus 3, 5. So 6 is greater than 5. So this truss called as imperfect redundant truss. Thank you.